it out. Okay, so let's move on to the fourth question. And here it says, and this is actually a good question to practice. Okay, so you are given an integer n, integer array nums. Okay, and in nums it is said like, okay, in nums it is saying a position I is called fixed point if nums of I is I. So that means if the value at index I is equals to I, okay, at index I, if I is the index and the value at that particular index is also I, then we call it a fixed position, fixed point. And we are allowed to delete any number of elements from the array including 0, and after each deletion the remaining element shifts by one position and the indexes are reassigned. So if I delete this 2, so this 1 will shift and this array will become 0 and 1. So means this 1 is now at position 1 instead of it's not at position 2 because 2 is now deleted if I go by example. And our goal is to like determine the maximum number of fixed points that can be achieved after performing any number of deletions. So that's the particular goal of this problem. So if you look at the constraint, it says nums of length is 10 to the power 5 and this. Okay, so what was my initial rule, right? What I thought for this particular problem, right? Let me just have a look. Let's first copy the question so that we know what we are doing. Okay. So I hope the question is visible. So what I initially thought is, let's say if you're given nums, right? Nums. So let it be like something like, let's understand better with some example or something, right? So that it's helpful to us as well. Okay, so let's take something like this 0 0, and let's say here it is 1 and here it is 1 and what is 3. So if you see like this particular index 0 1 2 3 4, right? If you see this value at index 0 the value is 0, so this is a fixed point. Okay, if you see this, is it a fixed point? No, it is not a fixed point, because if you see the value is 1, the value here at this particular index 1 is 0. Okay, so this is not a fixed point. Okay, and if you see here, right, is it a fixed point? No, because we wanted here, what is the value that we wanted? We wanted 2, right? And here if we want this to be fixed point, we wanted it 3, so this is also not fixed. And here we wanted value 4 if you wanted it to be fixed point. Okay, so this is our first intuition. Now my second intuition, okay, let me pick this index, right? How do I know like if this number can be fixed point or not, if it can be made fixed point or not? Okay, so let's say if here the number is 0, right? If I delete this particular number, this will become index, right? This will come at this particular index, right? And in that case it will become at index 0 the value is 0, so it will become a fixed point, right? So my initial finding from this particular problem was, okay, I thought, okay, when can a number, but let's say this is the number, right? So let's say here it is 0, here it is let's say it's 2, right? Right, here it is 0 0. Okay, and this can be 1. Can this 0, can this 1 be made a fixed point? Its index is 2, right? Can this 1 be made a fixed point? I guess yes. Why are you saying? Because if we delete this, it will become 0 and 1, right? And let's understand the second case, right? 0 0, and let's say it's 3, right? So if you see index is 0 1 2, right? Here, sorry, it's 0 1 2. Okay, can this 3 be made a fixed point? No. Why? Because if you want to make it a fixed point, we need to move it right, not left. Any number of deletion will just reduce it. If you want to make it a fixed point, it should go somewhere here, not here. Like it should come here, right? And for that we need to insert, but in our question it's given that we can't insert, we can only delete, right? So it's no. So what is the finding from this particular case is, if a number, right, if the number is greater than equals to its index, like if the number like this value it is greater than its index, then we can't, it can't be made a fixed point at any cost, because we are only given the option to delete or not delete, like stay the same or delete. Okay, so the major finding from this particular thing is, if nums of I, right, nums of I, if this value is greater than I, then no use, we can discard this, right? We can discard it, right? I hope this was actually understandable to you, right? So this is the first observation that I got from the particular question. Now let's jump back to this particular problem, right, that we had so far. So if you see, right, let me take it. So we had this particular array, right? Now I will just see, okay, if this wants to be a fixed point, how many number do I have to delete? Like 0, and it wants for fixed point, it is a 0, so I don't need to delete anything. So no deletion. No deletion. So no deletion I will represent this like let's say 0 deletion. No deletion is required. So if you want this number to be a fixed point, what should be its index? Its index should be 0, right? So its value is 0. And what is its current index? It is 1. So how many deletion is required? If you delete 1, it will be done. So I need 1 deletion. Similarly, for this particular index, how many deletion do I need? So its value is 1 and it's currently at 2 index. So if I delete any of the previous one, then it will become valid. So it needs 1 deletion. If you see this particular, right, what is the current value? It is 2. It is 1. Okay. And how many, and for it, if it wants to be a fixed point, it should be at index 1 right here. So I need to delete any two values from here. And how do we calculate this? Basically, like what is the value and what is the index? So we need to delete 2, right? And for this, if you see, it wants to be at index 3rd. So since the value is 3, so we need to delete any one value from here. So it will be 1. Okay. So I got one more thing, like how many values do I need to delete, right? Okay. And once I have got this particular thing, right, this is one of the most important thing that hints. Okay, so when I got this particular thing, what was my initial what was my next finding is, okay, since I have the difference that what I need, the only target is like it can go up, right? uh, so I'll see, okay, for this particular index, if you see, right, let's say this if I delete 0, it's fine. And this is saying, okay, I need to delete 1. Okay, I can delete 1. So I'll say, okay, I can delete 1, and this will form the answer, right? So I'll just form one particular thing, right? Okay, for this particular value, what, how many deletion I need? So number, I'll have a like nums and diff, like deletion or difference, whatever you say, right? So this 0 0 0 1, okay, and what is this 1 1 1 2 3 1, right? This is one particular thing that I have formed, right? Valid pairs, only this valid pair. Let's say here it was like something like 6, right? And here it will be 5. So how many deletions are needed? It will say, okay, I need to move right, I can't delete, so it's telling -1 deletion. That means I need to add 1. So I would have simply ignored this will not come in our valid pairs, like this particular array that we have formed, like since that can be discarded, right? This one is discarded. So I hope this part, up to this part is clear, right? And till here, when I got to know this, okay, so what I was thinking is, okay, so I'll find which element do I need to not delete it. So let's say if I have deleted something, right, if I say like I have deleted one number like this, right, and I have deleted one number like this, and next time this comes, let's say something like this comes, like let's say um, This is our particular example that I'm trying to understand. Let's say this was saying I need to delete one, right? No, not one, uh, 0. Okay, let's say it was telling delete one. Okay, and here it was like 2. Okay, okay, let's understand with this. Okay, so this is, well, this value is telling okay, you need to delete one to make me a valid one. So it is telling okay, delete one, delete one. Okay, deletion. And what is it telling? I don't need to delete anything because I'm at index, and this one will be invalid because it's lying again. Okay, and it is telling I need to delete. uh, I don't need to delete anything. You don't delete anything because if you delete anything I will come to index lesser. Okay, so let's say if I have deleted this one, okay, now this can't be valid, right? Because I have already deleted one. So this was one of the thinking, like okay, if I have deleted already something, the next number, if I have deleted, let's say three index, the next number says like I need only 2 index, it can't be a part of our answer because I've already deleted 3, so it can't come. So this was my initial thought. So what I thought is like I'll just sort it, like this particular, what is, how many deletions do I need, and by that order only I will try to form it. Like okay, so I'll say if I sort it, right, on what basis do I sort? So it will be 0 0. So how many deletions are needed, right? It will be based on the number of deletions that is needed. Okay, so we'll just sort it. So this particular is not, so we'll be sorting on how many number of deletions that we need. So 0 0, now 0 1. Okay, and if you have same number of deletions, then we'll prefer this like second one. Like that doesn't matter as much, but yeah. So let's say it will be 3 1. This will be uh, 1 1. This will be 0 1, and this will be uh, 1 2, right? We have got up to here. I hope this is understandable till now, right? Or what I could have done is like, yeah, so this is particular understandable. Or let me delete something, like I made this part complex, so let me erase it and let me explain it again to you. So I hope that simplifies the problem. So once we have till here, what I'm going to do is I will sort this particular valid array, valid pairs that I have formed. Okay, so why I'm sorting it, right? So that I can have something like okay, how the pairs are going to be rearranged. Okay, so once I have this, I'll sort it, and after sorting the array will becomes something like this will be 0 1. Okay, and this will be 0 0. This will be 1 2. This will be 1 1, and this will be 3 1. Now what does it means? It means if this number is at 0 and it needs one deletion, right? So if I have deleted already one, like this particular can't be an part of our answer because it says for 0 I have deleted already one, and this number again comes and it says okay, I need one deletion, I need 0 deletion, but I've already deleted one. So you can't be a part of my answer. Now this number comes and it says okay, I need 2 deletions, and I've already deleted one element, right? I've already deleted one element. Okay, so this can come and form okay, I can delete something more on the left and such that it can be a part of my answer, right? Now this one again comes and it says I need only one deletion, but I see I've already deleted 2, so you can't be a part of my answer, right? And if it comes and it says okay, I need only one deletion, but I've already formed a part of my answer, and you can't come, right? So that's how my initial intuition will be. Like I just need to form the LIS now, longest increasing subsequence, such that it can be something like 0 0. So in usually it's not strictly increasing, it can be same order 1 2. Okay, so if I see like, right, so my final thing, it doesn't depends on these parts, right? I just need to care on this particular thing, so I'll just separate it out. Like it will say how many deletions do I need actually. 0, 1, 2, 1 and 3. Now we need to find longest increasing non-decreasing sequence, you can say non-decreasing sequence. Okay, so how and to find this we already have two way. One way will be dp, that is O of n square, that you can take, but it will give TLE. The other one is binary search, BS, that is LIS, binary search. So you can have a look at this. I hope you know this, and we'll use this particular binary search one, LIS. So what is the initial thing? Like, since we have this, I'll just do a dry run to help you understand what actually this help goes, how it works. Okay, so initially we'll say DP, right? This is initially empty. Okay, and we'll run a loop over this, right? So this is 1, 0, 2, 1 and 3. Okay, so I'll first see, okay, if the array is empty, can I place it here? Okay, here I can place. Now it comes 1, right? So what I'm gonna do is I'll find an index here, like at what index this 0 fits here, right? It fits here, right? So I'll say, okay, I'll replace it with 0. So this particular becomes, so this is particular binary search actually. So this will become 0 at here. Now 2 comes. What is the value at which it sits? So okay, 2 can come here and 2 can align here. Okay, it's fine. Now next time, what comes is 1. Okay, so 1, which particular index is 1? If 1 wants to sit in between a particular this index, where it will sit? It will sit at this particular index, right? Because that's how binary search actually works, right? Uh, this will become 1. So I'll make it 1. Now it comes to 3. Okay, so 3 can come and 3 can sit here. So, okay, so and this is the final. So final, whatever is the size, will return the answer, return the size. And if you see how actually this worked, is like it says, okay, I'll pick something like 0 kill, like this one, and I said, okay, like usually it doesn't work like this, but yeah. So why the answer is 3, if you want to understand it, like usually it's binary search, but you can't be like this. So nums of 0 is 0. So if you look back and if you see right here, okay, so it can be something like 0, 1, 1, 3, right? So 0, 1 and 3. So we deleted this. Okay, so it will be 0, 1, 1 and 3. Now we deleted this, so it will become 0, 1 and 3. Though this binary search actually in LIS, it's not it the DP that we finally form, it doesn't represent the actual order, because if you go through the clear code of binary search LIS, it will explain like why this is not an this, but it just says us what is the size. So I hope this was the initial intuition behind this problem. So initially finding what is the move that I need to calculate, what is the distance, and this was one case where I need to discard which element to discard. And once I have discarded, so I'll form the valid pairs. So these are the valid pairs, and once I have the valid pair, I will just sort it. And once I have sorted it, so I know like I can do a binary search so that I can have it, right? So here basically what I did was like I deleted this one, like it was saying 1 deletions. Okay, so I deleted this one. Um so it remains at its own position, like not this one. So I left it like 1 deletion, so this become this and then this and this, right? So that's basically like how the code was working, like I hope. So this was the second part, and this is that once we have this, we'll just take out the second part, like how many deletions are needed. And once we had the deletions, we'll just form a longest non-decreasing subsequence, and we'll form the whatever is the size that we're able to, we'll get the binary search binary search variant of LIS, and that's how the code was. So the main part was like figuring out which to keep and which to not keep, because we can't element can't move on the right, it can only go left because the deletions are only allowed, not insertions. So this was the main part. So and once this was formed, after sorting, it just boils down to binary search using the LIS variant. So yeah, let's understand the code. So this is basically the vector. pair, and here I'm calculating the difference. If the difference is greater than 0, that is it needs to move on the left part, then we'll push it in our valid. So this is a particular array represent valid that I have spoken in the explanation, and then we'll sort it. So we're sorting it. Okay, and once we have sorted it using the comparator function, in which we keep the maximum, like if the values of a and b are equal, if in that case we'll take the bigger value first and the smaller value in the second part. And once we have this, so sorted it, so once we have sorted it, so it becomes like this. So once it becomes this, we'll extract out the second values, okay, and form a nums array or whatever, and then we'll just do a binary search using the LIS variant, and that will give us the answer. But since this is not strictly increasing, it is non-decreasing, so instead of the lower bound we can use an upper bound, and it will just give us the LIS. So in LIS variant we just need one change. Since it was non-decreasing, so it will be like upper bound instead of the lower bound, and that's particular intuition. More the main part was like this, forming this part, and then realizing like how we need to do a binary search. So yeah, this was pretty much for this particular problem, and I hope it was explained fairly easy to understand this particular problem. In case if you have any doubt, do feel free to reach out in the comment section. I'll be happy to help. And yeah, this was a good contest. So yeah, we'll meet in the next contest. Thank you.